Another lecture in the series of transducers, ultrasound transducers, also known as probes, scan heads, or scanners. This series discussing the basic components of the transducers, the non-imaging transducers, and imaging transducers. And here in this part, we're discussing the imaging transducers, and we have the mechanical and annular array, one group, array 1D transducers like the phase array, linear array, curvilinear, and tightly curved array. And the array 1.5 or 1.5D transducers, also array 2D transducers, and lastly we'll discuss the 3D and 4D imaging transducers or techniques. So this is here the last lecture for the transducers, and in this lecture we'll talk about the 3D and 4D imaging transducers, or actually it's not only the transducer, it's a whole set of technique or a whole set of electronics in the machine, and we'll come to this in a moment. So 3D and 4D imaging transducers. Okay. To define first what is the 3D is imaging. Okay, 3D imaging is scanning a volume. So we are not talking about a section, only a section that you can, what we call a slice, and you present it as an image or one frame or multiple frames on the screen. This is not the 3D. The 3D, you are scanning a volume, and that's why in 3D we will add something now, a term, we'll use it, which is called sweeping. So in 3D imaging, we are scanning a volume. That's why the scanning plane should go over this volume in a sweep pattern. So it sweeps the volume. So now we have a different term to use, which is sweeping of the scanning plane. I'm having one scanning plane, but it's sweeping across the volume. So in this way, I will get multiple or many 2D images. These 2D images are sent to some like processors in the electronics of the machine, and these processors will take these multiple 2D images, put them one by one, back to back, and will build a virtual 3D image of what's being scanned. Okay, so so again, this is the 3D imaging, is scanning a volume using many 2D images that are placed together. This is the processor will do that. We put these images together so they are saved and arranged in sequence to build at the end to get what? To form a 3D image. Okay. What is 4D is real-time 3D. So the process here is repeated many times along while you are scanning. So this is like a live 3D. So 4D is what is a real-time or live 3D imaging. Okay. So for this 3D imaging to be performed, there are, like I told you, we have three main steps or three main like cornerstones in the building of the 3D and 4D imaging process. First one, sweep. Okay, sweep scanning. Like I told you, we will have here a term called sweeping that we didn't use it when you talk about 2D, because 2D we have a fixed scanning plane. So the scanning plane is look here, but I will not use multiple scanning planes to build a volume. So sweeping is the term here. So sweeping again, this is the first step, and this first step, the sweeping through steeping, what we will get, you will get data acquisition. The electronics of the machine, it will acquire the data so that at the end, not at the end, I mean during the processing, it will take these images to build the 3D. So first here what we have, data acquisition techniques. And we have three techniques actually for to get this data acquired by the machine. The second step is processing. So this data that been acquired, they will be processed. And in the processing here, the machine is using a voxel. So what is the voxel? The building unit of a 3D. This is comparable to the pixel that the machine is using to build the 2D image. So the 2D imaging, the machine is using pixels, but in the 3D imaging, the machine is using voxels. So voxels, like of course, I think we are all familiar with the cubes. Like I don't know, I don't want to use the term like Lego or whatever, but this is like you build something 3D. You have to build cubes. You put cubes together, you get a 3D, right? So these cubes, these are the building units for the 3D. So we have small cubes. We call them voxels. Okay. So these voxels are used for reconstruction. Okay, so voxel reconstruction. After that, we will get the rendering. Rendering is the way that the display, the rendering here is in the processing, and the rendered image will be sent to the display. So the display will display what? The rendered image, and we have different ways of rendering. Okay, so again, we have a data acquisition, we have voxel reconstruction, which is building a virtual 3D volume. It's virtually in the electronics in the machine, and then we'll get what we call rendering. And this rendering, we will have this 3D volume is displayed in different ways based on how this 3D virtual volume being rendered in what we call surface rendering or volume rendering. And we'll have this when it comes to the point of rendering. Okay, guys? So sweeping, or what we call data acquisition, is done through three techniques actually. Okay, so sweeping again, like I told you, it's a volume scanning by sweeping of 2D imaging planes. So sweeping of these 2D imaging planes is swept, or one plane that is swept along the volume, okay, and inserting them into what you call the voxel of a predefined volume grid. So we need to know that in the next step, which is the processing, we will get a predefined volume grid. So when you have this, we'll come to this later on, that we have this machine will build a volume. There is a preset empty voxel that should be filled. And this empty voxel together will make what we call a volume grid. So each machine has its own volume grid. And whenever you scan, this volume grid should be fulfilled by the voxels. Okay. So we'll talk to this and we'll talk about it in the coming process. But now we are in the process of sweeping. Here we have three methods of sweep. There's manual sweeping, and this is sometimes called the freehand sweep. Okay, and this is no more use. It's one of the very old techniques of acquiring 3D imaging by the manual sweeping, but it's no longer in the market. The second one, which is the mechanical sweeping, and this is actually the commonest one. If you are practicing some 3D imaging or whatever, you might feel that the probe is having some vibrations. Okay, this is the mechanical sweeping, and we'll discuss this in a moment. The third way of sweeping is called electronic sweeping, and this electronic sweeping, this is the latest technology, and this is the one that is using what we call the 2D array transducers. Remember when we were discussing the 1D, 1.5D, and 2D arrays, okay? We have the 2D arrays that we have the columns and rows are the same number. This is what we call the 2D array transducer. This is the one that is used here in the electronic sweeping, all right? So we go first for the manual sweeping. Manual sweeping, it was in the past, but no longer in the market now. And this is when you have the probe. Usually this technique is using your old probe, that is the one that you use in the 2D, but then the company will come add some electronics in the machine to acquire a 3D volume. So what happened here? You put the probe over the volume you are scanning, and then you move it by your hand. So this is manual sweeping. You move it by your hand like here. How the machine will recognize where the probe is, because it needs to get these cuts, put them together to form the image, okay? How the machine is recognize this plane or this plane to put them together, okay? How this is happen? Because the probe here, there is like a clip attachment that is having a receiver. And on the other side of the image, not the other side, I mean next to the probe, there is a source that is creating a magnetic field. So it's transmitting magnetic field. This magnetic field, of course, like a field, we have three, so X, Y, and Z. So because a three-dimensional field. And this field is sensed by this receiver. And the receiver is connected with a wire. And this wire is hooking to the machine. And wherever you move the probe, the receiver here will sense where the probe is and will like label each frame. This frame should be at this location, like the GPS is telling you where are you or all over the planet. So this is the same. Okay. So there is kind of like GPS detector with the probe, and this will tell the probe where it is, and the machine will put the frame according this location. So now this is the machine will take all of these images or this through sweeping, manual sweeping. I will build the 3D imaging here. Okay, so this is here the manual or the freehand sweep of 1D array transducers. Okay, with the attached magnetic field sensors. So this is here the manual, and this is no longer in the market because it has a lot of defects based on you might not use the sweep in one line. You might get like a zigzag line. This will confuse the image. Or you might use the probe in the straight line, but not the same sweeping speed. So you might move it fast and then slow and then fast. So there's a lot of problems here with this manual or the freehand sweeping, and that's why it's no longer no longer anymore. So the second way of sweeping is the mechanical. Mechanical sweeping here is using an electric motor. So this is like an example of the 3D imaging probe using mechanical sweeping. What is this? There's an electric motor here, and this electric motor is using some sort of like a belt. This belt will transmit the movement to like a lever inside here. This lever is holding a 1D or probably like 1.5D array here inside. So this array is moved across from side to side. So this is sweeping. So the volume is here. There is an array that brings this image. So this is like a scanning plane. And this scanning plane is swept across the 2D. So along this sweeping, the machine will acquire the data based on this sweeping. So this sweeping, it has a certain technique, which is mechanical sweep. Mechanical sweep probes are using electric motor for sweeping 1D array transfers. Okay. So this is another, the second technique of sweeping. And actually, this is the commonest one that you are having in the market now, which is a mechanical sweep of electronic probe. Now we come to the electronic sweeping. Electronic sweeping is what? Like I told you, we have the 2D probe. It should be the 2D array probe. 2D array probe. So the active elements are arranged in many rows and in many columns. They are almost the same number. That's why they're giving 2D. So 2D electronic probe, okay, that is having multiple crystals. If I'm assuming that we have 100 columns, 100 rows, so this transducer contains 10,000 active elements. You see here it's a huge number, and it has a huge like active processor, that very high speed processor, to process all the data acquired by these 10,000 elements. So again, like it's not only the probe, it's the whole electronic setting of the machine and the build. So this is here electronic sweep. This is using 2D array. This is the one I told you earlier when you're discussing the 1.5 or 1D, so 1D or 1.5D or 2D. I told you that the 2D array probe is using in what? This is electronic sweeping of the 3D imaging, okay? What happens here? Each group of these will send a scanning plane, will receive the reflections, and will send them to the receiver. Okay, and the receiver will send it to the scan converter and will build the image. So that's why we have what? All these are sent almost in the same time, and you will get a 3D image that is built right away. So that's why it's the best way to get a 4D imaging that is having flicker free. This is the one that it can achieve this. So this 2D array transducer is best way to achieve a 3D imaging without flicker. Okay, so this is that probe, and sometimes it's called the matrix probe. Okay, that acquire image information by electronics scanning using multiple scan planes. Okay, so now we have the whole volume now is almost scanned instantaneously from this end to this end, or the whole volume, and will be processed later on like almost simultaneous with this high technology machine. So we finished sweeping. Now come to the next point, which is called processing. Processing of 3D, we need to know that it's one of the techniques of post-processing. Okay, we'll come to this later on when I start to give lectures about the instrumentation. But as we know that we have in the processing, which is it's done in the scan converter, we have something called pre-processing, and we have post-processing. Okay, so 3D imaging on all the techniques is a post-processing. Why? Because after the scanning planes are built, they are processed together to build the 3D. So 3D imaging is an example of post-processing. Like among other examples, okay, 3D imaging is an example of post-processing. Okay, in this step, the post-processing, or the processing of the multiple scans, now we have all these are delivered, okay, to the scan converter, that the scan converter will take all of these, this specific very high-tech converter. It will take this scanning plane and will make what we call a virtual 3D image. Okay, so this step is taken in two steps actually. The image processing is divided into two steps. First one is reconstruction, and as I told you here, we have something called like a pre-formed or pre-prepared grid of voxels. So they are empty spaces that are in cubes, very small, very minute cubes. Okay, and this is like a already built grid inside the electronics, and what you scan, it will be filling this grid. So this is reconstruction. By this step, what happened? The machine will build a 3D volume, a virtual volume inside the image, inside the electronics. Okay, so we don't see it except when it comes to the display. When it comes to the display, okay, this will be first, this 3D volume, it should be rendered into a display. So before display, there must be a step called rendering. The rendering is again in the image processing. So rendering is what? I will get, or the machine will take this volume that is already reconstructed, and this will rendering into a display. This display will have later on by rendering, we'll discuss it. We have two types of rendering. So this is the reconstruction first. Reconstruction means what? We have a grid. This is like a grid. It's made of voxels. These are empty voxels. They are in the predefined volume grid. So there is a predefined volume grid, and electronically, I mean, okay, we don't see it physically, but there is a predefined electronic volume grid that is waiting for the voxel to be filled. So what is the voxel? The voxel is the building unit of a 3D and 4D imaging. So what is the voxel? It's the building unit of 3D and 4D. This is a common question. You will see it in the SPI. So what happened here? So this is volume grid here, okay, like this. Inside it, all the voxels, when they are finished, I will get here inside, which is the virtual volume that's been set inside this predefined grid. So there is a predefined volume grid made of voxels. These voxels will be finished or will be filled by the data acquired by 3D sweeping. Okay, so we finished the reconstruction. Now we come to the next step in image processing, which is the rendering. What happened in rendering? Okay, that this 3D volume that has been like built inside the scan converter is rendered to be displayed. So rendering here, we have two ways of rendering. Volume rendering, sometimes called the tissue rendering, that you can get the 3D volume here, and you by this 3D volume, you can display it in different ways. You can get what you call to obtain endless number of images. Okay, you might have, I want to scan like transverse, you get transverse cuts. You might get coronal cuts. You might get sagittal cuts and parasagittal cuts. You might get oblique, either right to left or left to right, or oblique anterior to posterior or posterior to anterior. So all these are endless, actually is endless number of cuttings or imaging orientations, okay, out from this 3D volume that is being built already inside the machine. So there's a virtual volume, and whatever the cut you want, you can get it out of this 3D volume. So this is what is called volume rendering. Some people call it the tissue rendering, because you can get, as if you're scanning already, the preset scan, you can get the tissue echogenesis, you can see all the organs, whatever the inside. So this is sometimes called the volume rendering or tissue rendering. And by tissue rendering, you can get what? Endless number of imaging orientations. So this is like these three parts here. This is the volume rendering. And now we can get what we call the surface rendering. Surface rendering, this is one only on the display. And this is the, you render, or the machine will render for you the out surface of this volume. So in this way, I need to have some different echogenesis. So I have to have, for example, a fluid around the face of the baby. And this is actually the one, this surface rendering, this is the one that's been used commonly in the what they call the studios of 3D, 4D scanning. Okay, they are using the surface rendering. There's some statement about the 3D, 4D imaging, okay, and the safety of the ultrasound. And this statement is by the IOM. We need to put it in our mind, okay? So although there are no confirmed biological effects on patients caused by exposures from the present or the current diagnostic ultrasound instrumentation, the setting of the machines, okay? The possibility exists, still exists, because no reported cases, but still the possibility exists that such biological effects or the bioeffects may be identified in the future. Thus, ultrasound should be used in a prudent manner to provide medical benefit to the patient, okay? Not for fun. Okay, guys? Thank you, and I hope this is again, I hope that this clarifies some of the points. And by this one, this is the end of the transducers. I built, or I put all the lectures based on the transducer from the beginning to the end. From the beginning, that what are the basic components, to the end here, which is 3D, 4D, and we'll see you later in the instrumentations. I'm preparing some instrumentations. Thank you, and have a good one.